Okay. So it's a simple Angular component, right? This is the rendering of this component. I have a few questions. First of all, what do you think? How many JavaScript files currently are on this page? I'm talking about the render page, right? Like where the component actually already rendered. Who think it's more than 2 files? Let's assume it's a production build. Who think it's 1 file? Okay. Who think it's more than 2 files? Like way more. Okay. What about the total weight of these JavaScript files? Who think it's more than 300K? Who think it's more than 100K? Okay, everybody else thinks it's less than 100K? 50K? The Angular application, okay. Basically here apparently it's only 1.2K. Okay, the main reason because there is no Angular. Okay, so okay, so what we see here is a decorator. Okay, it's a simple decorator, custom. It's very messy code, but basically that's what it does. Okay, it's just based on the configuration passed into the decorator creates the simple HTML element. That's it. This is just an example of what decorators can do. My name is Daniel, and I'm a web team lead at Kaltura. I'm in industry, in web development, more than 20 years. Basically, lately I began to be a full cycle developer, backend, frontend, DevOps, whatever, everything from idea to production. That's it. This is my Twitter, Medium. So please follow me on Twitter. I want to get above 100 followers. Let's start. So today we'll talk about decorators. It will be like split it for 2 sections. One of them is more like history. What is decorators, where it come from, proposals and all this, and then actual the examples. Okay, the examples in live coding. I hope this will be more interesting than the first part. So let's see. First of all, what is decorator is? It's a design pattern. Okay, was described in the book back in 1994. One of the most well-known 23 design patterns. The explanation is pretty simple: to extend the functionality of classes and the methods in clean and declarative fashion. See, it's not something new, it's very old, and if somebody of you work with Python, basically into JavaScript, then to TypeScript, decorators came from Python. Okay, that's where it comes from. Now, disclaimer, decorators are not part of the JavaScript, they are part of the TypeScript, and they are in stage 2 of the TC39 proposal process, if somebody familiar with this. Saying that decorators are highly used in TypeScript in frameworks like Angular, NestJS, MobiX. There's also some libraries that already have pre-built and predefined decorators that you can use, such as core decorators and low-dash decorators, for example. It's very have like wide variety, but more than 50 different decorators. Very, very, very useful. You don't have like create by yourself. You can use already existing ones. The guy who actually proposed the decorators was Yehuda Katz back in 2015. I see somebody who's laughing. Yeah, right. It's the wrong guy. This is the guy. This is Yehuda Katz. Okay. But by the way, the previous picture is the first one that you see on the Google pictures when you look in for Yehuda Katz. Okay. By the way, this face more famous like this one, right? Everybody knows it's Ember.js. And his proposal was: decorator is an expression that evaluates new function that takes the target name and property descriptor as an argument, and optionally returns a property descriptor to install and on the target object. Now, this is the original proposal back in 2015. It's changed a lot because this proposal is relevant only for the method decorators. Since then, it was added class decorators, property decorators, params decorators, and whatever. So it's this is like original proposal. Common use cases for decorators, there are a lot. starting from a logger, different helpers, performance measuring, code analyzing, memorization such as caching, access control authentication, web worker runner, fully anti-pattern decorator, okay, but works and I love it. But it's when I showed it on one of the meetups in my country, I got like 10 people came, hey, it's cool. Another 10 people came, hey, you can do it. It's we will kill you for this and stuff like this. Class mixing and class composite, also very interesting. And and basically decorators also widely used for meta programming around on the object-oriented programming. Now, before we jump into the decorators, into the examples, there's some base. I will try to run it fast, okay, over this section. But just to be sure, I don't know like who's beginners, who's advanced developer, but I want to be at least on some point aligned on some knowledge, okay? So we have a descriptor, okay? Descriptor is kind of metadata for the object property, okay? If you have a simple object, to do object with a property summary, pass the 100 followers on Twitter, assigned of course to me, deadline, if I remember, it's for tomorrow. So to get the descriptor, for example, for the property deadline, all we need to do is to use the static method on object, get on property descriptor, we pass in the object itself, and the key, the string, the name of the property we want to get the descriptor of. Console of the descriptor will show this output value, the actual property value, in our case this long number, it's a timestamp. Writable is a boolean, that is actually value, it represents if this value can be changed, okay, if we can change the original value or not. If we will set writable to false, we will get an exception that you cannot assign value to the read-only. Enumerable, also boolean, meaning if when you're iterating over the object properties, if you will iterate it, it will just skip it. Okay, for example, if you will get the object keys onto the object, so if the enumerable is false, you won't get this property in the array. Okay, and the results of object keys. The same with the for-let key of object. The same if the enumerable will set on the property, on the descriptor of the property to false, so it will just skip this property. Saying that, need to remember that still the object has own property will still return true. Okay, so it doesn't change this fact. Configurable, that basically says if you can change the descriptor. Okay, setting the configurable to false, you're not able to change writable or enumerable or configurable. Okay, so basically it's kind of freezing. You have to define the object from the beginning. Okay, this is the meaning of the descriptor. Basic example for the decorator, for class member decorator, we have a to-do object, okay, with the and the decorator itself. So, what is decorator? It's the way that we call the higher order function. Okay, it's basically a function that takes another function, extends its behavior, hopefully without changing it. Okay, because I saw a lot of examples and tutorials about the decorators that start with, hey, we got in the function, we can just return the other function. Okay, with other logic, with whatever we want. Or we have a target in our decorator, so we can add properties on it or whatever. Okay, I don't think it's a smart thing to do. Since then, nobody don't know actually what you're doing. So I prefer to say, hey, please do not change logic, business logic of the function, the method that you decorated in your decorators. Add indicator for the parser that we actually use in decorator, and read only it's a name of our high order function. Okay, that's decorator accept target, basically our to-do object, key, the name of the property, string, the name of the property that we decorate, and the descriptor, the same we would get with the get on property descriptor and passing the object and the name of the property or the method in our case. TypeScript signatures typing for the decorators. As you can see, we have a method decorator. Okay, that accept target is an object property that can be string or symbol. Descriptor, it's typed property descriptor. Property decorator, a little bit different, okay? It's accept target and property key, the name of the property, but does not have descriptor, just because the decorator evaluates in the compilation time, and in compilation time, all properties are undefined. Class decorator accept actually the function, it's accept the constructor, okay, the constructor function. And parameter decorator, that accept the target, the class of our method, the property key of our method, and the parameter index. The index of the parameter is stated on the method signature. Okay, we'll see it later. Okay, I hope it's just Google Translate. I hope it's okay. But yes, I have one more disclaimer to say. I'm the only probably Ukrainian Russian speaking guy who came from Israel to Italy will speak on English. So sorry for my English, and in case I'm switching to Hebrew or Russian, just let me know. Let's start with examples. Yeah, it works. Cool. Basic decorator examples. So what we can see here. Okay, so basically we're looking at a simple my class, okay, with some method primes that returns number of prime numbers in the past big number, okay. It's calculated, actually it saves it. And what the decorator that you saw, also the same decorator that you saw on in the presentation itself a few slides ago, the read only, okay. So what we're doing here, we're actually changing the descriptor writable of this decorator to false, okay. And now if I will try to hack my method, so price equal to something else, I don't care about this, I cannot assign the read-only primes, okay? Definitely if somebody else will want to really hack it, in this case, for example, he just take the descriptor manually, okay, by using object getOnProperty descriptor, change the writable to true, hack the function, return to false, and he will be able to hack it. But anyway, it's very useful. This decorator is very simple, like one linear decorator, but it's very useful for public libraries, okay, for public APIs, in case you creating some API, object, class, whatever, that somebody else will use it, and you won't be sure that nobody will override it, or at least if somebody overrides, he need to do it in purpose and not by mistake. Okay, so this is one of the simples and I think very useful decorators that can be shown as example. Now, the another one is of course log. The question about when to use and when to not use the decorators. The logging, I think, it's one of the most easiest way to show. During development, I don't know how about you, but sometimes, or let's say sometimes not, usually always, what I'm doing, I'm putting the console log on beginning of the function, on the end of the function, because I want to know when it was fired, what the parameters was passed to it, and what the result was returned. Okay, especially when it's large, huge application. And last time I've been on this code half year ago, and I don't know what's going on and where it's called from, and I want to debug it because there's somebody find the H bug on this, so I need actually to start console log or put a debug everywhere or something like this, and then, but I only want to know what actually the function, all the data around the function, when it fired, the parameters it was passed, the results it returns, and maybe some time measuring if the performance is important for me. Okay, so putting log here. Okay. Okay, we'll basically output. Let me just comment out all this to be clear. Okay. Compilation time method primes was fired. Okay, the name of our method. The argument passed to the primes. That what actually was passed into it. Starting execution primes, the result, and the method primes was completed. Okay, pretty simple. All log is there. Of course, I can send some parameters, some configuration to this logger saying, hey, first of all, I want only the execution time, or I want only the arguments that was passed to it, or I can change logger that I'm passing into it. Okay, so let's look at the implementation of the logger. Not everybody together. Okay, so implementation of the log. I'll use this. Okay, so signature. Okay, accept target key and our descriptor. The compilation time when it's actually compiled. Okay, and this is the runtime. Now, how we can log the runtime function? What we're doing here, we're saving the value, the descriptor value is our original function, our original method, primes. So I'm setting it on side, some const, and I'm hacking it actually, overriding with my own function. In this function, I can do whatever I want, but one of the most important things is to not forget execute the original function and to return the result. Okay? So here I have access to all arguments that was passed. I can validate them. I can print them. Okay? I can postpone if I want to. For example, there's the bounce decorator that can to postpone the execution of the decorated function. So this is one of the I have full power above my method, above the decorated method. Okay, and of course I do not forget to return the result of this of the decorated of the results of the invocation of the decorated method. Okay. Let's go back. Timer.
Yeah, so when does it happen? I mean, when it happens that the decorator, because you are just overwriting the function. When does it happen that the decorator overrides the function before the execution of the?
Basically, what is that? Okay, the decorator, it's compiled during the compilation. Okay, so this is the let's look at the. Okay. So this part will compile. This console log happened only, okay, during the compilation. Here's an example, by the way. Let's look at on the example. Let's go back a little bit with the log. Okay. I'm cleaning this. I'm removing the invocation, and you see only the compilation log. Okay, because the function wasn't fired yet, wasn't executed, the decorated function. Okay, so you see this? It's come from this log. So this is the compilation time. Now the runtime actually, when I'm changing the original value, and the original value is prime. So basically, if I will print, or let's say, will run to script over the method. After the instantiation, after the decorator, you will see all this code inside of it.
You're talking about compilation time TypeScript-wise, not JavaScript-wise.
I mean JavaScript-wise.
JavaScript, you're using the JavaScript decorator now?
No, it's a TypeScript. It's a TypeScript decorator that compiles to JavaScript and then.
Okay. I think it's all because it's difficult.
Yeah. Okay. Let's continue to the timer. So, and now, just let's one more time. I'm firing the decorator, and then I see the compilation and the actual invocation of the function. Okay? Let's look at the timer. Now, timer will show me the execution time of the method. Okay, 130 milliseconds. One of the nice things about loggers and timers and all these decorators, helpful decorators, is that I can actually pass my own logger function. Okay? That means I can pass my logger function that probably won't do console log, but send it somewhere else, okay, on some third-party service, logs.io or whatever, some service to collect all logs, okay? Very easy to create, instead of to do all these console logs, especially, for example, in timer, okay? If I have some critical functions, critical methods that time assuming, okay, that have a lot of data processes and stuff like this, and I want to measure this data, and I also can pass, for example, the minimum or the maximum value for the login, okay? If it's passed more than, if its function runs more than 500 milliseconds, log it, okay? And then I will get the logs in on some other system or something like this. Clear up to here? Okay, everybody sleeps? Okay. Don't worry, it will be more boring later. So. Deprecate. Okay, also very useful example. In case I want to deprecate on init only. Okay. Again, very useful for the public APIs, for the public libraries, when we want to notify our users that on next version or the version after that, this method or this class or this property or this whatever will be deprecated. Okay, so basically you don't need to write some logic. Just put the decorator and it will notify. It will be now. And also you can, again, example to showing the difference between running time and compilation time as an example. Okay, you can just put some configuration. Okay, you can just add whatever configuration you want. In this case, I have configuration object that accept on init only, true or false. That means it runs only once. Okay, only during the compilation time when the application is starting to execute. Or again, you see it once. The function was fired twice, but the log was actually prints only once. Or I can put it to the false, and then each time when I using this function, never mind what, it will also send a warning that, hey, this function will be deprecated. Please pay attention. Okay. Let's look at the implementation of this too. This is the deprecate options. Okay, for example, URL. They can pass link for the additional data. Okay, about the deprecation, what have to be changed, etc. The default message that I can also pass to, and then instead of this deprecation, my class and primes, it will actually print the message that I'm passing to. On init only that we talked about it. Okay. Here's our deprecate, accept the options, and then basically simple logic, right? It's about if it's here we have also validation if the descriptor value is a function or not. Okay, because if it's not a function, we have a problem with this decorator. Here's a method signature. Okay, we've taken the target, constructor, and the name to get the class name. Okay, because we really want to be informative to the user, not like, hey, there is some method deprecated, but what the class is, where is sitting on the class, and the name of the method itself. URL if exists, so we will add it to the message. Here's the interesting part where we check an if it's an on init only. If it's on init only, so let's just let's warn and return the descriptor. That's it. But if it's not on init only, so let's continue and do the same trick. Okay, let's save the origin function on site, and let's use let's change with our own function where we actually will fire, where we print the console warn each time when the method was fired, each time when the method was invoked. Seriously, 15 minutes left and I have another 10 examples. Okay.
Only a minute and you have 5 minutes for the question.
Since I don't like questions, so I will take over. Okay. So I will skip about the property log, but the cache it, for example, it can be interesting too. Let's use cache it, right, and timer. Right. Change this. Okay, let's look at this example for a second. I'm using here two decorators. Okay, I'm chaining the decorators. I have the timer and cache it. Now, the cache it basically what it does, it saves the previous answer, and if it's already was fired with the same arguments, it will return the, the previous results of the function. Pretty useful. Kind of memorizing, but very simplified in this case. Okay, without usage, the memo is a library or something like this. So let's look. What I'm doing here, I'm firing 3 times the same function. Okay, with the different values. 2 of them are the same with the same params. Let's just to be more. Okay, and let's look what we have here. So as a result, we have 900 milliseconds, 100 milliseconds, and 0, 1. Okay, because the last one already was fired as the first, and then actually we got the results. Also, nice and useful for caching things and to make a little bit more performance. Especially, you don't have to, check if it's the values and everything. Like everything is already there inside of the decorator. Not this decorator, okay, and the implementation of this decorator is simplified, especially for the demonstration only, okay, like the code is for demonstration purpose only, not for the production, okay. So yes, what we're doing here, we're actually creating some kind of cache and doing some join of all arguments, and if it exists, or return, if not exists, I'm doing the apply and the results and assigning the results to the object, okay. Pretty simple, nothing special. I have another example. One game. I have 5 minutes more? Okay. I have an example. I have a game. It's all about priority. It's one of the important things. Okay. It's the priority of invocation of compilation of the decorators. Okay. First of all, it's method and the properties decorator that runs from top to bottom, like a regular script. Okay. Then arguments decorator. Okay, parameter decorator of the methods. Then class decorator, and then parameter constructor decorator. So you can see it here. It's just dummy class with decorators all over the all options. Okay, to see that what was invoked. Okay, property decorator, method, parameter decorator immediate after the method, and then class decorator, and the last one constructor parameter decorator. Okay, it's very important when you're playing with a lot of decorators. You want to understand which one, especially when you do add some data to the object, okay, to the class or to the property. You want to understand when it's already exists and when not. Okay, so chaining. Here's chaining. Okay, chaining decorators is the way when you actually can chain decorators one after another one, like we saw in the previous example with the cache it and timing. So let's play the game. My class, okay, 2 methods. Both return the same value, 5. Okay, some method A, some method B. On one of them we have decorator multiplied by factor 3. On both of them, we have a decorator multiple by factor 3, and in both of them, we have a decorator add 1000. Okay? You with me? It's clear so far? So, on one of these methods, we'll do, first of all, take the results from the method, multiply by 3, and we'll add 1000. In another method, it will do the opposite. First of all, add 1000, then multiply by 3. Clean? Great. Okay. Okay, I will move it down, that we will see the methods. And here, you see the methods, okay? Here's the results. There's a previous guessing from somebody. Okay, raise your hands who think that method A will return 3015. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's say 8 people. Who think that some method B will return 3015? 1, 2, 3, 4, 5, 6. Okay, 6 people. Who thinks some method A will return 1015? 1, 2. That's it? 3, 4, 5, 6, 7. Okay. Some method B will return 1015? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say 10 people. Okay. Now, the decorators, they compile from top to bottom, but the execution goes from bottom to top. Okay, so let's see the results. Method A returns 3015. Method B returns 1015. Okay? So congratulate, you can get from organizers prizes for the correct answers, but I don't believe they will give you. Okay. Talked about the priority, talked about the chain. The last one. Not the last one, but IOTS. I heard about the IOTS, to be honest, today it's the first time, okay? But I like the idea very much. So I decided let's use it in Decorator too. Why not? Okay? And here's an example what basically shows that here's a TS validator that accepts as a parameter our type, okay? The type created by IOTS. Sorry if I'm saying here mistakes or something, because again I don't familiar too much with all names regarding to IOTS, but this is a type and the number of the index of the param that we want to validate in the signature of the function, okay? In this case, it will be the first one, 0, 1. And here's the 3 different calls where I'm passing the object, okay, with different values. Here's a string, here's a number and string, and then actually the valid one with the both numbers, okay? This is how I described my type. And this is the result, okay? So we have an error, and no errors. So also can be used in decorators. For example, you can notify, hey, you have an error, or you can raise an exception or whatever. Also can be useful, for my opinion, can be useful with external APIs, like public libraries, that usually if somebody don't like the typing that you use and put any on it, but you can do anyway validation if it's even if it's come with any instead. Okay. Now class decorators have to be okay. Have to show it at least once. Basically, class decorators in one. It's class decorators is one of the how to say it, biggest thing that I've know about the decorators that can be, because there's can be done a lot of things around the meta programming with the class decorators. Okay, with regular all other decorators too, but the class decorators, you haven't full access to the target, to the class, and you can do whatever you want. So basically that's what Angular does, okay, with the component and all the decorators in it. This example shows simple validator for a number of arguments that class knows to accept in constructor, and number of arguments passed during the instantiation of the object. Okay, you can just check if number of these arguments is equal okay, identifier, okay. For this is what we're passing, this is the accepted, required, okay. Pretty simple validator to ensure that somebody who uses your class, okay, especially when again it's out of public libraries and stuff like this, they pass in the exact number of arguments, and of course you can, to make it a little bit more robust, like to pass with the IOTS, okay, the configuration would have to be in this, what exactly have to be validated, etc. I skipped this slide about the decorators, and thank you. Questions? Hopefully not.
Hi, nice talk. A question about decorators. I'm a common developer. I talk with common people, I do common things. I don't know if use decorators because maybe they are going to change in the future. Maybe look what happens with the import that happened at mess. So the question is, are you confident that using the decorators now with the current syntax, it will be almost safe in the future, so I don't have to change all my code base if I start using decorators? Thank you.
I see. I think, okay, first of all, it's a good point. Okay, it's a good thing, thing to think about it before you start using the decorators. But looking at the history, and currently TypeScript is pushing into decorators. Okay, and basically they pretty finalized the description of how it's called. The description of the decorator, the specification of the decorators, how it used to be, okay? And it's very close to the JavaScript in proposal, in TC39, okay? Now, it's stage 2 in JavaScript, because, most of you don't like JavaScript, and when it's here, it's like, but let's be honest, a lot of things that go into JavaScript, then they run into TypeScript, and both ways, okay? So, as soon as it will be approved in JavaScript and then implemented in our engines, etc., that will be absolutely the same on TypeScript. Okay, they won't change it. I don't believe they will change it. Okay, they will just recompile your code by using the same decorators in JavaScript. So I think it's pretty safe to use it now, especially when applications like libraries or like Angular and NestJS using it all over. I don't think that Google will run into decorators so deep like they do it with Angular without thinking if do we need to do it or maybe not. No, I think they are actually absolutely convinced that it's a production ready thing. Anybody else?
I am a bit worried about the amount of new syntax that has come in TypeScript in the last years. I mean, following the ECMAScript, we have every day more symbols, and sometimes those symbols have different meaning. It depends on when you use it. It's not the case with decorators because you have only one meaning, but as you showed me, you have different types of decorators, and it depends on where you use. Sometimes it happens to me that I have to teach TypeScript and JavaScript to people that aren't programmers, so I see that it's increasingly hard to explain out of those symbols. And I like the readability of decorators, but I was wondering if there's a way in which I can achieve the same results, but using some more primitive constructs, syntax constructs. If you have functions, it was easy because you can use higher order functions, but in method of classes, it's not very easy. So I was wondering if you
Why
have a
not?
way.
It's absolutely the same.
Absolutely the same.
What is the constructor of the class? It's a simple function, nothing but a simple function that actually sets some values on the prototype, okay, and that's it. It's a simple function. It's nothing else but function. That's why to decorate classes, it's not so difficult. It's the same as to decorate method or property, okay. And the difference that in the method you got more arguments into the function because you have the class itself, the target, the key, the name, and the descriptor. When you decorate the class, you got only the target, and you have everything on it. So you got actually it's like to decorate the class is like to decorate the constructor. It's absolutely the same. So you have this method, okay, and you can return other classes if you want. That's how actually class mixing works or composite. Okay, when you decorate. I have this example, but I'm not going to show it. When you decorate some class, okay, for example, I don't know, my car, and I composite mixing decorator, and I'm passing there, for example, flying, and it adds the whole functionality, altitude, latitude, set, fly, etc. to my class, okay. It's like extend, but on easy way, and more than that, I can put 10 of them. Okay, I can put 10 classes and composite some big, robust, class with a lot of functionality, with all the different, configuration, etc. So, I think, decorators, for me, for example, it's much simpler and easier to understand. Definitely much easier to read the code with decorators than the higher order functions. Okay, because when you have the function that return the function, some const. And then like, what's going on here? Okay, but if you have the informative decorator that above the function, so I will understand what is going on there. And as soon as I know only one of these decorators, and I meet in other places of the code, I know what's going on there. Especially when you don't change the logic of the decorated method. Okay, if you won't change the logic of decorated methods, it will be even more readable and understandable for everybody. So, thank you.
My question to you is, does people who are not developers do exist? Thank you, Daniel. Thank you.
Thank you.
If you have a developer